In this question, we're going to look at the question 4, which is the linear regression equation question again. A study was carried out in a large automobile factory to investigate the relationship between a worker and the level of the worker's age and the level of absenteeism. The following data concerning 10 randomly chosen employees were collected. There's the data set there of the ages of 10 employees plus the number of days they have missed. And now, in the first question, we're asked to draw the scatter plot. I'm not going to do that in this presentation. I've done it in the previous presentation. So what I'm just going to sort of remark upon is the fact that there are quite a lot of additional summations given and sums of squares identities. So these sums of squares identities, essentially they're mathematical formulas that are just they're the building blocks of equations. And we actually will use these, so just make a mental note of those when you sort of read this exam paper. So, also, just actually, where'd that come from? If you look at the back of the exam paper, the formula sheet will actually make reference to these identities here. So, let's answer the first question. Calculate the correlation coefficient and interpret its value. So from the back of the exam paper we have this formula here, and it's the correlation coefficient, and it's equal to S of xy divided by the square root of sxx times syy. So let's calculate that. R is equal to, there's the S of xy, let's put that over the line, minus 283.8. And we're going to divide that by the square root of S of xx, 613.6, times S of yy, which is 148.9. What we're going to do now is a little bit of calculator work, but our answer should work out to be minus 0.939. Just as a quick remark, interpret its value. Well, just recall that the correlation coefficient should be between minus 1 and 1. And if it's very close to either 1, if it's very close to minus 1, we say it's a negative relationship, and if it's very close to 1, we say it's a very strong positive relationship. So, if you looking at, be mindful of the scatter plot question that was done previously. This, we would say, is a very strong negative linear relationship. That's all we have to, that's pretty much the interpretation we would make from a correlation coefficient like that. Okay. So that's that part done. We're going to move on now to the next part. We're going to compute the regression equation. And again, we're looking at the back of the exam paper there. The first term we're going to compute is the slope estimate, and then we are going to compute the intercept estimate. Now, what essentially we have to do is construct this equation, an equation of this form here. This is the intercept estimate, first off, B0 plus b of 1 times x. Now these are some coefficients that we have to determine. B0 is and B1. B1 we'll do first. B1 equals s of xy. So that is minus 283.8, and divide that by s of xx, 613.6. We leave that to be minus 0.46. So far, so good. The next part we're going to do is the intercept estimate, and you just make note of the fact that we have to use the mean of y and the mean of x, which is the mean number of days they've missed and the mean age. So we can actually compute those quite easily. Y bar, the average age, is simply the sum of the y values divided by n. N here is 10. Just recall that there are 10 people in the data set. So it's 61 divided by 10, and that's equal to 6.1. Likewise, X bar there is 318 divided by 10, 31.8. Okay, so now we can compute the intercept estimate. B0 equals 6.1 minus two minus signs, 0.46 times 31.8. That's a bit of calculator work, and we should get an answer of 20.73. So 20.73. To 2 decimal places. It's just more or less around that on your calculator. So we're ready to write out the regression equation, the line of the regression equation here. I'll actually just put it in here, make it a bit make a bit deal of it. Y bar equals 20.73 minus 0.46x. Okay. X is age, Y is the estimated number of days missed. Now, we're asked to interpret the values quickly. So, essentially, what we're saying is, let's interpret the slope first. If we increase X by 1 unit, so if we increase X by 1 unit, this means we cause a decrease in number of days missed. That implies decrease of Y by a unit of 0.46. So, like, for every unit increase in X, there's a decrease of Y in 0.46. And again, you can sort of say if we increase the age by 1 unit in the model, it'll cause a decrease in the number of days missed by 0.46 units. Okay, so that's the slope estimate. The intercept estimate means, like, if the age is 0, we expect the number of days missed to be 20.73. Now, that question is sort of very deliberate. It's actually just it makes you sort of think about linear models and the limitations. So according to this model, we can have a newborn baby in the model, and he or she will only miss 20.73 working days on average, according to this model. So it doesn't really make sometimes the models are very limited. Okay, so if X equals 0, then Y, the estimate for Y is 20.73. So those are the two interpretations. Okay.